Welcome to PHYS1111 Fundamentals of Physics. So in this first video I will just run through a few brief points on why these videos are useful to you and also what you'll need to know before coming into the lab each week. So these videos themselves, they're just designed to be a short brief intro to the topic for each lab, and each one will go through some basic theory and an intro to the topic. You'll get a brief demo in the lab of what you actually need to do. And finally, I'll go through some useful hints and common mistakes, things that you can just revise a bit before you come in to give you a better chance of finishing everything on time. So what do you need to do before coming into the lab? You need to make sure that you've got your safety induction completed and you're coming in with the correct footwear each week. You need to do the pre-lab quiz, and also don't forget to bring in your lab manual each week because you need it for each lab. What you should hope to get out of it. So hopefully these videos will just give you a good understanding of what you actually need to do in the lab so you can come in, sit down, start working straight away, and also be confident with the concepts behind each lab. So lastly, feedback. These are fairly new videos, so it would be great to see what you think. Let us know if they're helping you or if it just seems like a waste of time, but any feedback you could give us would be helpful so we can improve these for future. So thank you, and also don't forget that your demonstrator's here to help in every lab, so ask them if you have any questions. Hello, welcome to the introduction experiment. So first of all, I'll just go through some learning outcomes for the experiment. You'll learn how to do some basic measurements around the lab. You'll learn about uncertainties. You'll be doing some linear graphing methods, and also you'll be learning how to interpret these linear equations that you're graphing, both with the computer and by hand. So how are we achieving this? Part one, you'll be looking at calculating the density of a brass cylinder and then calculated its associated uncertainty. Next, you'll be doing a straight line fitting exercise, first doing it by hand drawing in your error bars and getting lines of best fit with minimum and maximum, and figuring out how to calculate uncertainty with this method. And yes, and then you can compare the uncertainties with each of these methods and see how they compare. So see you in the lab. So for this first part of the experiment, you're just trying to calculate the density of a brass cylinder. So they'll be in this green box, which your demonstrator will show you where it is. And all you need to do is weigh it on this set of scales. And apart from that, you'll need to measure the height so you can calculate the volume of your cylinder. For the second part of the experiment, when you get to the computer work, when you're looking at fitting errors, you need to log into the computer, so you'll just be using your ZID and your ZPass. So this is what it should look like when you get it open. I'll just mention one small thing. When you see the capital letter E in your equation, that E means 10 to the power of. So 2e minus 1 means 2 times 10 to the power of minus 1. So any questions you have with this lab, just please ask your demonstrator, but the lab manual should lead you through all of the problems that you need to do for this first lab. So enjoy. Okay, so I'll just go through some common questions and mistakes made in this first lab. It's important that you understand these ones because they will come up in every lab hereafter. So just spend the time on these if you need to understand them better. So firstly, let's look at significant figures. Let's say that you've weighed a mass at 50.1 grams plus or minus 0.05. The important thing here is that we want you to match the decimal places in your uncertainty to that of your actual value. So you can either round up your uncertainty to 0.1 here or add an extra 0 to your value so that both your value and your uncertainty are the same decimal place. Either is acceptable, please be consistent though. Secondly, unit conversion. It's important you understand this before coming into the lab. So we'll go through just an example just to make sure. So cubic centimetres to cubic metres. You should know that 1 metre is equal to 100 centimetres. If you convert this to scientific notation, making centimetres the subject, you have 1 centimetre is equal to 10 to the minus 2 metres. You can then substitute this into 1 cubic centimetre, which gives you that 1 cubic centimetre is equal to 10 to the minus 2 metres all cubed. Then if you do the math on that, you get 10 to the minus 6 metres cubed. Another thing that people can struggle with for the first time is interpreting the physics from a linear equation. So I'll go through an example. say that you're plotting the velocity of a ball as it falls at different time intervals to try and figure out the initial velocity and acceleration. So if you plot v on the y-axis and your time on the x-axis, and you plot a straight line fit to your data points, you'll get y equals mx plus b, just the standard form of a linear equation. Now, if you notice that this is in the exact same form of the relationship that we're looking for. So y is just your v, and on the x-axis is t, as I said. So the important thing is here that you can find what you're looking for by looking at both the coefficient of what's on the x-axis and your y-intercept. So here the acceleration is just equal to the slope, and your initial velocity is just equal to the y-intercept. Lastly, I'll show you how to properly draw your min and max and best fit lines for a data set. So say you've got some points here, they've got associated errors with it, so you draw in your error bars in the x and y, then you draw your best line fit, and so this is supposed to pass through as many points as possible, and as a general rule of thumb, you'll have just as many points above the line as below the line. To find your min and max fit lines, you will need to draw a box around your error margins for the first point and the last point. Then your maximum line will go through the bottom right-hand corner of the first point and the top left-hand corner of the last point. This is because you want to encompass as many of the possible values as possible. Similarly, your min line will go through the top left-hand corner of your bottom point and the bottom right-hand corner of your top point. So notice here that the B min is actually higher than B max. This doesn't matter, it's just a convention to keep the minimum slope and minimum y-intercept values in the same equation. But you'll be looking at the range of these values, so it doesn't really matter which one is greater than the other. Okay, that's it for this lab, so I hope you enjoy it and good luck.